Hello and welcome to Experiment 2, Food Dye Analysis. Our objective for this experiment is to determine the amount of the food dye red number 40 in one piece of candy. This experiment built off of what we learned in the spectrophotometer lab, which was that there is a linear relationship between the absorbance of a solution and the concentration of a substance in that solution, a relationship we refer to as Beer's law. We'll be able to answer our question today experimentally in two parts. In the first part, part A, we're going to prepare several known solutions of red 40. The idea then being that once we have these known solutions, we'll then measure the absorbance of these known solutions, and then from that absorbance and the concentration of these known solutions, construct a Beer's law plot. That Beer's law plot then will give us an equation that's going to allow us to relate the absorbance of any red 40 solution, such as the red 40 solution from our candy, into its concentration. So to do that, we're provided first a 5.80 times 10 minus 5 molar red 40 stock solution. This is the solution from which we'll prepare all the other diluted solutions. We'll prepare specifically 6 other diluted solutions, and we want to be very careful about making these solutions as accurately as possible. So we'll use a 10 milliliter volumetric flask to contain 10 milliliters of solution, and then to deliver various volumes of the stock red 40 solution, we'll use what's called a 1,000 microliter to 5,000 microliter micropipette. And that's going to allow us to very accurately and precisely deliver these known volumes of the stock solution. So if we know the volumes of the stock solution, we know the total volumes of each solution, we're able to then calculate the concentration of red 40 in each of these solutions. It's in the video, but also in your lab notebook, you want to use the dilution equation to show how we actually did calculate those numbers. And then also in the video, you'll be able to record the absorbance that was determined for each of these 7 solutions at the wavelength of maximum absorbance. Once we've made all of our known red 40 solutions and have measured their absorbance at the lambda max for red number 40, we'll then construct a Beer's law plot. Beer's law plot, as always, is a plot of the absorbance at the lambda max of that particular solution versus the molar concentration of the substance. If we carefully prepared our solutions, we should get a nice linear relationship between the absorbance and the concentration as predicted by Beer's law. Absorbance is equal to epsilon times path length times concentration. Specifically, once we plotted our data, we can then draw a linear trend line through our data points. Excel will give us the equation in the form of y equals mx plus b, or m, as we talked about in the first experiment, is a determination of the product of the molarity of red 40 times path length. We call that for our cuvettes, path length is always 1 centimeter. In any case, though, once we have this equation, we'll then apply this equation once we determine the absorbance of our unknown red 40 solution that we'll prepare from the candy. Notice that y is absorbance, x is concentration. We'll get the concentration of the solution from the candy, x, from knowing the absorbance of that unknown solution. In the second part of the experiment, then, we'll turn our attention to both preparing and measuring an unknown red 40 solution, specifically an unknown red 40 solution from our candy. This candy is coated with a water-soluble red 40 food dye. So our very simple procedural idea is that we're able to remove that red 40 by dissolving in a known quantity of deionized water. This is an important number to take note of from the video because we'll be using this number a little bit later on in our calculations. Given enough time then, this red 40 is expected to come off of the candy, dissolve into the water, and it certainly will, but in addition to the red 40 food dye, other materials will also come off the candy and ultimately will cloud up our mixture. We don't want to use a cloudy mixture for the spectrophotometer because that will affect our absorbance measurements. That's one of the discussion questions we'll talk about here in a little bit. So in order to get a more appropriate mixture for our instrument, we want to remove this cloudiness as much as possible. One option we have then is to use a centrifuge. The centrifuge will remove most, if not all, of the cloudiness from our mixture and leave us with not only a colored solution, but also a clear or translucent solution. With the solution then, we can then determine the absorbance of our unknown solution, determine as a result then from the Beer's law plot, be able to calculate what the concentration of red 40 is in this mixture. Using our Beer's law plot, specifically the equation y equals mx plus b, where we plug in y for absorbance of our unknown, and then solve for x, which is in the concentration, the molar concentration of red 40 in this container. Then using our how much deionized water we originally added, that's the volume of the unknown. We can then convert our molarity, moles per liter, into a moles, an amount of red 40 in moles. And then finally, using our prelab assignment, we'll then be able to convert from moles of red 40 into grams of red 40, and finally grams of red 40 into milligrams of red 40. When you write your lab report for this experiment, it's very important that you write this lab report with as much detail and as carefully for this online experiment as you would if this were an in-person experiment. So just to remind us, we have a pre-lab assignment. Make sure you write full and detailed procedures based upon what you observe in the video, including all qualitative and quantitative observations. The results section at minimum should include a properly labeled Beer's law plot. Make sure you show your work for all unique calculations. And then a little bit later, we'll talk about the discussion questions. What you're going to turn in are both your original pages as well as your copy pages, your yellow pages, but they'll have separate due dates. And so please take note of what's on Moodle about when these due dates are for both pages are due, but they'll both be turned in to your instructor's Dropbox. And then finally, some discussion questions. First, just simply answer the question a day. So what is the mass in milligrams of red number 40 in one piece of candy? As always, take into account significant figures. Secondly is, based upon what we observe in the video, do we think it's likely that our value, our experimental value, is too high or too low compared to the true value? Obviously, we probably have no idea of what that true value is, but based upon some experimental assumptions or maybe even experimental error, how do we think we erred? Is it too high or too low? Explain your reasoning. And then finally, why was it necessary as part of the procedure in the video, why was it necessary to centrifuge that initial food dye mixture? Could we have used other procedures, other lab techniques that you're already familiar with, perhaps, to remedy this problem? And if this step were skipped, in other words, if we just simply determine the absorbance of this initial food dye mixture without further procedural steps, how would ultimately that have affected our experimentally determined amount of red 40? Would that have made that number too high or too low? And then always make sure you explain your reasoning.